Welcome everyone at the next multi-network community sync. Today is November 6th, and we are continuing our discussion on the DRA integration. Today we want to touch on the scheduler integration. Any other topics before we start with this one? I want to bring up. Yeah, otherwise let's just, so I'm not sure anyone had the chance to read into this. I managed to do it a bit. Let me share this. So what I learned is there are two ways to use the scheduling. Maybe share this tab here. So DRA calls out two ways to control the scheduler. Basically, identify which node has how many resources. And the first one is control plane based. What does this one means is there is an object the scheduler will create, and it's called what is it? It was somewhere here. Pod scheduling object. Maybe it's named differently, but basically what happens at the end is scheduler, as it starts to schedule a specific pod, it will look at the pod, see, oh, you have some resource claims. And then what it will do, it will identify that this is the way you want to go with the control plane based approach. So it will create for you a pod scheduling object and wait. And basically now you must have a controller of your own that will appropriately update that object. Yes, Lionel.
I'm not. I will check, but I think this is deprecated. This part.
Is this deprecated, you think? So I'm calling this one out. I'm just describing this, but I explicitly would not want to go with this approach. I would want to go with the structured parameters approach, but I want to call it out that it's there, unless you're saying it's deprecated. The documentation doesn't.
Yeah, I think it's called. It was called classic DRA, and then you had a controller with an API from
Right.
Kubernetes
So
that was putting this.
unless that's and basically it's the main thing with this description I started is it blocks scheduler completely. So this pod scheduling object is created, and scheduler waits for your controller to update that object. And there was a ways to kind of scheduler was showing initial list of nodes where this can go, and then the controller would say, okay, only these nodes satisfy the needs, and only then scheduler will move on. This interfered with the pod startup a lot, right? As you can feel and you can see, scheduler just gets to that pod and stops, and basically it affects all the other pods because if I'm not mistaken, scheduler is single thread, so it just blocks and waits until your controller updates this object, and then when it does, it moves on. So it's A, error prone, as probably that's why it was deprecated, and B, slows down the whole kind of processing of pods. So yeah, moving on. And I personally, I wouldn't want to go with this approach neither. So
Just
and
to
this
mention
one
about
calls out.
the deprecation, just about the deprecation, is it's deprecated as part of 1.32. So it will be deprecated in the next release.
Oh, okay.
I mean,
So
it will
basically
not
that's
be
why
there anymore.
all right. Yeah. So let's skip that then completely. So the structure is parameters. This is a bit better approach, which basically what it does, it requires the drivers, and here whoever implements the multi-networking to specify what sort of resources do you have and how much of it you have. So basically this is very, and then the scheduler just looks into that resource. So the resource is named, where was I seeing this resource claim? Resource slice. So basically this is a very straightforward object where you create one per node. So, and basically each driver on each node is supposed to create that. that has a consequence, right? Because then the whole resourcing of multi-network, I'm not sure whether there can be anything we can add. We probably can build some libraries, but it will be fully owned by the drivers, so the implementations. Basically, resource slice, you just define in a spec what sort of devices you have. You put some attributes to it, so descriptors. This is where, Lionel, you were calling out the cell expressions last week. This is where that comes in here, because then I can do some more sophisticated ways on how I pick and choose the devices, because across the node I can have multiple resource slices, and basically I want to call out that I want this specific driver version or device type or what's not. So basically the attributes is the ways to describe that. And then there is a capacity, which is a key value approach, a map that basically you put wherever you need. And basically the resource can be let's say IP addresses, right? And then you put some number to it, and that's it. Did I pick the structure parts? Yeah, I picked the right one. Resource slice, and basically, let's maybe zoom a bit here. Close this. So it has the driver, so who's responsible for the slice. There is as well means to pull. I'm seeing from the APIs you can pull that slice in some ways. That's kind of strange. I'm not sure how that works. I assume you can have then maybe one per whole cluster. So you have one of the three options on how limited the slice is, whether you provide data per cluster, per node, per selected set of nodes, or single node, right? So a node name, node selector, or all nodes, right? So one of the three. This is kind of, I'm not sure. This is counterintuitive. If maybe there is a ways to use a resource globally. I don't know how that works. Depending on, probably for us, if it was an IP, this can be then global, right? And that's fair point, right? Then we can, if I, let's say, have an IPAM, which is not per node, and I use let's say I have a VLAN based network, Mac VLAN, and I have one subnet with /24 for the whole thing. So yeah, that's where probably this goes in. So basically I can create a all node slice, which says that I have devices for this, which basically are represented by IPs, but then I can treat them globally rather than locally per node, because the IPs are virtual. So I don't really care. I just need to have cluster-wide tracking of this object. And I assume when it's all nodes, then you can create a controller. Okay, so this is where probably we can chip in and say that, yes, we can do this. And then there is devices, and devices are defined somewhere here. Yeah, string and basic device, and basically this is what I want to get to. So attributes, as I said, a map. You can provide a set of attributes. I think the names has to be a DNS type, a naming schema. Same with the capacity, right? And this is just a descriptor. Those are only descriptors. And here you specify how much of it you have. And this is where I'm a bit vague, because I haven't seen an example for this. I saw some, but maybe something there is a better here. I saw one in the previous doc, but it was kind of vague, like memory for a device that was a resource. So this is where I'm hand waving. I'm not sure how this is supposed to be explicitly used. Let me try to find some, maybe there is some example in this doc. Yeah, that's kind of the gist of this. Anyone, Lionel, do you have maybe more? Have you really into this maybe, or anyone else in the meeting? Maybe I'm missing some key aspects.
To mention that I think this is for like the device, the full device itself, and they have another cap for what's it called, partitionable devices, where you can take one part of the device. But I think they are also talking about virtual devices, and I think it's what we are interested in because we are
Yeah.
creating device on top of other device. We have ETH1 on the node, and we want to create a Mac VLAN, for example, on top of that node.
So that's where I don't think that's important on that point, right? Because if I go with virtual, let's say Mac VLAN on top of the ETH1, the ETH1 is not, okay, there are two aspects to this maybe. It matters if ETH1 can be used for something else as well. Maybe that's where it matters, right? Let's say ETH1 is I am inside a VM and ETH1 is a VF passed to it. And I have two options. I can treat it as a standard net device and I just want to create Mac VLANs on top of it. And I agree with you, then that's fair because then I can sub-device it and then that's unlimited. Or I can treat the parent, the whole thing, as a SRIOV device, right? Or maybe just a host device, right? Where, okay, I want to pass the whole thing into the pod, but then that means I cannot create any, that parent is gone, right? I cannot create sub-devices off of it. Or other way around to look at it, if I already have some sub-devices on top of it, I am blocked of using that parent as a host device, right? So I think this is where this would fit and that will be useful. I think in this point, Lionel, it will boil down to the driver implementation. I think here what we need to look at, because all the slice and dicing of of whether it's SROV, host device, VFs, whatever you name, whatever you wish to do, this is where the implementation comes into play, right? And you mess around that, since it is the what I want to say, it is the driver's job to create the slice. It is its implementation, how they want to slice and dice this, that will be defined. What I think what we can do though is, since the DRA is all lists and what's not, what we can do is we can maybe standardize on the IPAM for this. What do I mean by that? So you see how here resource template, the request is a list, right? And here what we can say is we will always, when we create that template out of a pod network, right, we can always create the first item to identify the IPAM defined. And basically this is where we can standardize. This is what I mentioned before, right? What if we had a I usually call it global IPAM, except in opposition to per node IPAM. So with global IPAM, we can create a controller that will represent the IP, right? And basically then it will be limitation, right, for the how many pods I can create in a cluster based on how many IPs are assigned for the specific pod network, right? This is a bit tricky because we never talked about IPAM in terms of how we assign specific range to a pod network. This is something that was always external, but this is something that we maybe can at least provide a means on how we can do. I think what it would boil down to though is how we do define what sort of additional devices do I have to pass to the template, right? I think this is where will be the question mark, right? Because we would create a pod network. Let me see, does he have a diagram of some? I don't think he has. Maybe this. Yeah, I think this is somehow good, right? So we have our resource template, right? To what I think controller is creating, and then creating a resource claim out of it and assigns to a pod through the template, right? Because this is the dotted line shows here. And basically then the resource claim, we deal with the resource slice, right? To kind of identify how many of specific resources I do have across the cluster. So the question would be, how do we match, if we were to do what I mentioned, right? There will be one device called an IP resource, right? and then the other device will be whatever the implementation has. And what you said, Lionel, let's say that's a sub resource out of a ATH1, right? Because that can be that. How do we make sure that we can pass that and make it flexible into the controller to kind of support such approach, right? What I mean by that is the controller that would create the resource claims template. Considering pod network is our front end CRD, out of which we will create the resource claim, how do I now control what sort of data I have to put into the pod network to make sure my resource claim created is correct? So I think this is something that maybe we need to look at. And I think maybe the device class is the answer. Maybe not. I'm not sure. So device class is something that we probably can as well deal with, because then we can create, instead of just having a special name. What did we decided on the name? I forgot in terms of, let me share this tab for now. What we were talking last week, right? About the how do we specify so that's the name. And I think, where did we say? Oh, here. Okay, parameters. Okay, that would specify that it's multi-network. What if is there no device class in the template? I wonder. Let me see on the share this stuff, because then maybe through device class is something that we can somehow control that. Let me just see the device class. Oh, there it is. Okay. So device class, what does it has? It has selectors and a config. Define. Device selector. This is device. Let's see. Yeah, device configuration. This is all this. So driver and some parameters. Okay, and there is a driver. Okay, so just that. I'm not sure. Oh, parameters, is that the same, Lionel? So this is the same parameters that I think that
in my POC, it's where I put the CNI config in my POC.
Right. So basically that's the same, right? So device class can have that configuration. So maybe then our controller just looks at the device class in the node in the pod network. We point to a device class, and that will point out, okay, what sort of devices this pod network would require. I think then we have the full flexibility, right? Pod network is the front end. It points to a device class, which means of it's like a provider, right? That's device class for you. And out of that, we are creating the templates, right? Out of the device class. So we are borrowing. We don't even have to borrow, right? We just create the templates that points to that device class. Considering this is the same thing as the other parameters, right? So we just require the, but then we put, okay, yeah, because then we push the configuration of this onto the user, and we are not fully obscuring the DRA API. So maybe that's not the best. That's the trade-off, maybe, because what we were talking last week was to, okay, user just creates the pod network, and the controller that we would have completely would replace the we'll create the DRA objects as needed, right? So we don't have to, so the user doesn't have to worry about it. I think that approach is better. So the question would be, what sort of configuration do we want to do, if any, in terms of the scheduler, right? Let me see, share this stuff. And this is where you were saying, Lionel, as well, where if we create this object, we might obscure the scheduler in some ways. Yeah, that might be the case. Yes, Pooja.
Sorry, just one question. So when you said last time it was discussed that the user would create the pod network, and then the controller automatically will create the DRA
Yes.
object. The pod network would be a device class, or
No, the pod network would say, let's say we have now right now a provider in the pod network. I'm sharing the right one, right? You can see what I'm marking, right?
yeah.
Yeah. So you would have a provider, or here instead of that, device class, right? That would point to what sort of any specialized devices I need in my claim, right? Maybe that can be optional. Then the device class can be optional, and on top of whatever we create, then we use the device class to append any additional requirements that your what I want to say, that your driver requires, right?
so for example, if we do decide the device class here, it could be, say, for example, a Mac VLAN. So we are basically saying
No, I
attach.
would say I think device class would rather mean um, multus. I would say this is device class multus,
Oh,
which
okay.
which then or multus MacVLAN, maybe you're right, because then what it means, it will define what sort of devices do I require. But maybe before I go there with the
Okay.
list, Lionel, does if I have a config, if I have multiple items in this list, in this opaque list here, config, right? It has multiple. Does that mean that I need each dash, each item here is a separate device, or basically I need one device that has these attributes? How do I?
So
Because
like
devices, right? Okay,
the
so this is
it,
devices.
it's about the requests. The requests will based on how the driver is implemented, will provide you one or multiple device,
Mm.
and the requests are getting some parameters so that are in this config, and
Mm.
yeah, config can be shared between multiple requests.
But the request is on a level of what? Request is on a level of that item in a
Config,
config, right?
yeah,
So
yeah, you can have
basically it's
multiple config.
no, but then each config has its own, each config item has its own requests. That's what I'm confused. So basically I can have this, right? Let's maybe simplify it a bit. What I mean by
Yeah,
that.
you can have two config with
Uh,
for the same request. You can have one config for two different requests.
am
So
I
yeah, it's
aligned here? I think I might be, hopefully. Let's say this. So
yes,
now
I guess.
here this, I will remove that so that it's shorter. But then, can you repeat? Sorry, what did you say? That what? Because that's kind of so. Right
You
now
can
I
have
can. Mhm.
you can have multiple config for one request, and you can have one config that points to multiple requests.
Oh, so basically I can have one config and points to MacVLAN 8080, and then I can have another config points to again to 8080. Is that what you say?
Yes.
Oh, okay. Oh yeah, that's what we would want, right? So basically, because out of a single claim, I want one interface, right? And then I want to provide multiple configurations. That's what I'm getting at, right? Because each config, each driver is a condition for scheduler. This is how I'm seeing it, right? So you can have driver multi-network doing the, let's say, the IPAM story, and then I have a driver multus, which does its own sub devices, or what's that, right? So basically, then this is how I'm opening the flexibility to implementation to add their own stuff. Uh, does everyone, did I miss anyone, or is that kind of clear? With this, we can have the flexibility of how I slice and dice the whole thing. Of course, it's always boils down to just single request, but multiple configs. And then I can have a driver. Let's say this will be This would be a multi-network. Let's say, oh, no, Control Z. What did I do? I think this. Yeah, this. So let's say I will have that. So this will be my driver. This will be our community driver. No, not that. But let's say this is multi-network community, or let's say IP resource dot multi-network community. So this is just a generic one to say, okay, the IPAM is something that we will implement, right? Or provide a kind of example of how that can be done. And if you want to use it, your class can then include this guy and that guy. And the other guy is whatever your implementation requires, right? That's thoughts. I think this will boil down to parameters. I assume the parameters probably could be the same, so we can replicate this, right? Same.
And so
we
you're
don't have
thinking, Maciej, that if we had a ETH1, then that would be a separate resource claim template? Or
no, so this is for a single interface, right? This is a request for a single interface. This is what I'm getting at, right? So this is Mac VLAN ETH0. The thing here, what I'm trying to call out is how can I leverage the scheduler, right? Because now with each driver defined and each being different, right? Let's say this is the case, right? First driver is Multus, the second driver is something that we defined, right? Then what happens is the scheduler has to look at two drivers. The one that we delivered, a common one across the community, standardized by multi-network effort by us. And then there is another one that's where you can plug in and then you can create your own driver that does additional. So when scheduler comes in, it looks at the slice, resource slice from this and from that for the same resource though, right? So that's what I'm getting at. So this is how we can make it flexible so that, okay, mine stuff is a FPGA or some, FPGA that basically slice and dices the network accordingly. And then I have my own ways on how that resource is divided. So I create my own driver for it, right? And then I can easily add it here on top of the IPAM story that basically the community provides, right? Because I always need IP for that device, right? For some reason, just throwing an example. So I think this gives us the flexibility of mixing multiple drivers, right? Anyone that we would build, some generic ones, plus anything your implementation would have. Thoughts? Requests. I see there is a device class name, allocation mode, exact count one. So class is defined here, but that's fine, right? Because that's what you want to say, that the class would have all those specified, kind of. Yeah, I think that's something that I need to read into more into device class itself, how that looks like. But I think there's some ways to open the flexibility of defining your own driver in here. And to be honest, the IP resource thing, this is just an example. I don't think we have to do it. This is just, I think, what if we were to do this, and how we can open up the flexibility of the array and the whole pod network to allow this, right? Any other questions to this? Or this is somehow clear? Lionel, do you know whether the SAP devices, is that going to be still via slices, or that's completely new approach they are taking?
You mean the partitionable devices or the virtual devices?
All virtual devices and all that. Is that part of the slice or approach, or that's completely new resource they are introducing?
But partitionable, I think it's via this resource slice, but I haven't really read about it. And virtual devices, it's nothing has been done about it. It's just it has been brought up someday, but because of this VLAN interface and stuff like that. But some people will need to work on it. So a new CAP will have to be created and stuff like that.
So I see DRA partitionable devices. I see that. But you said there was I'm looking at the caps. Let me share this stuff. So this is that container restart. I see the
it's
where was it?
4815. Yeah.
Yeah, but this one is the virtual as well. No,
No, it's only partitionable devices.
partitionable.
Virtual
Yeah,
is not created. It has been brought up during the meeting someday, but
gotcha. I see. I see. I see.
nothing is done yet.
Share this stuff. Let me see. Okay, so this is the partitionable, right? Resource. So this is resource claim, proposal design. So slice spec. There are device mixins that they want to do. So name and composite. Okay, so they are repeating the same thing. I wonder. I think, yeah, we need to read into this more, but yeah, that's something. I think then it's still, I'm seeing this is just enhancement to the drivers themselves, right? And how they can even further enhance their scheduling capabilities. From our point of view, I don't think that's so important, right? Or am I missing something? Let me know. What do you think?
Like, let's say, I think it was a problem with Multus, because Multus lacks this scheduling feature. And if you have a VLAN, I don't know, 4000, for example, that you attach to your pod, and you have another pod that requests this VLAN 4000, you don't want it to be scheduled on the same node because it will fail. You cannot have two VLAN with the same ID with the same master on the same node.
Right, but this is where the driver comes in, right? This is where your driver will now have, you have now means to create a driver in your implementation. And I'm looking at
Right.
Multus now.
So I think I think you guys might be saying the same thing because it's like, so Lionel's explaining, hey, here's an example limitation with VLAN CNI. Now you could actually check it with your driver, right? So you would make an extension to do this, to say like, hey, I know the VLANs, I know which ones where that's been exhausted, and now I can schedule it onto the right place. Lionel, did I understand what you were driving
Yeah.
at correctly? Okay, cool.
Yeah, perfect. Thanks.
So what I want to make sure that that's what's clear is all that is not subject of this community. That's what I'm getting at. I want to kind of define the means to do it, but then it's up to the Multus now to write the driver to properly create the resource slices to identify which node has what. And Lionel, you are creating a CNI implementation as well there with the NRI approach. Same goes here, right? Same story, right? You just, in your driver, you have to ensure you can create that slice to kind of propagate or identify what's where. And this is what I want to kind of call out. This here, what we want to do is just call out the APIs, the handles, right, for this. The underlying is just part of the implementation side, right?
And I do think that this stuff is good to write down the like potential usage here, because at least to me, it's like when I hear an idea like Lionel mentions, like, hey, here's a thing that's challenging to like manage without automation, that you would have to baby it the whole way, and now you could build intelligence to it. I think that excites me a little bit. I'm not always so, it's like that's clearly better than what we have today with
Yeah.
just CNI and Multis alone. Like that's awesome. Here's another so another kind of use case for me would be non-uniform environments. So could you build something as part of your driver to like introspect your nodes, learn something about the devices that are available, maybe the quote unquote networks that are available. Like if you say, hey, can I reach this subnet on this node? Then yes, I want that. If I can reach subnet A on node A, that means I have connectivity to network red. And I can
So,
schedule. Yeah.
and that fair point, Doug. So this is where I think we are in a bit of a, so I will tell you a crossroad here, what we can say, or what we could do. Because what you said is quite valid here. We can abstract the whole thing into what you just said, which network is available where. Just that, and that's a high level abstraction, right? And what you just said through a subnet, but I can apply it to anything, right? A network A is available only on the nodes where the specific SRV interface is. Same
Totally.
thing.
Or whatever criteria makes sense
Yeah,
for you. Yeah. Can
yeah.
I reach
So
this
so
IP? Can I reach this subnet? Can
so
I
so so the
have
question
this?
here would be: do we want to abstract this to the level of pod network is available here and there, or do we want to leave that open? Because that's what I was initially thinking. Or do you want to keep that open and leave the driver to identify what resource is available where? In your example, Doug, with the subnetting, right? This is where basically the IPAM thingy will step in, right? But I think in your case, it has to be more sophisticated, right? Because, okay, this specific subnet is only available on nodes A and B, right? And other subnet is available on C and D. And then I have to have a driver that A, recognizes which subnet is assigned to what pod network. And then based on that, I say, okay, node A has 5 IPs of that guy, and node B has 5 IPs of that guy as well. And then the other guy looks at the other networks and say, okay, subnet B now is available only on C and D nodes, right? Accordingly, right? And you can achieve the same thing. The thing is just the naming is different, right? You either say abstracted level, okay, I have a pod network available on a specific nodes, or we say your driver says what sort of resources that network requires, and you handle that. If we abstract it to a pod network, I think that might be a bit tricky. That might be a bit tricky because then we would have to kind of re-implement a plugins to the drivers, right? Because we still have to make it somehow pluginable for the implementations on how do I indicate a per node data, right? What does that, what do I mean by that, right? So if we say we abstract it, right? Let's say a network. So basically we take over the whole resource slice creation, right? And that's maybe the resource slice creation, we would take it over, and then we control what sort of values that resource slice has per each node. We, as this controller that I have, that would create the template out of pod network, right? So if we control that, then we take that full power and the flexibility from the drivers, and then we have to expose some sort of APIs or what's not to those drivers to indicate, okay, which and how much of a specific pod network you have per node. So the question is, do we want that abstraction? Do we need it? Or should we just leave the whole DRA APIs to the implementations? And wherever, let's say, new things come along, you can just leverage them. Because from our point of view, we are just gonna create you a template, resource claim template that will point to your driver, and whatever your driver exposes through the resource slice, that's what you get. Do you see the difference? Well, what are the two kind of ways we could go about this?
Yeah, I think I get it. I do currently lean towards making it driver specific rather than
Right.
trying to handle it at the pod network level, just mostly because I think that it, one, simplifies our work here, and then two, it gives you the total flexibility at the driver level. So I do kind of lean towards that, but I am, yeah, I'm getting excited about the potential for where like the DRA scheduling will
Yeah.
help me with more like virtual type of network resources. Because there's sometimes where I wonder, like, hey, are we adding a bunch of overhead to people for something that could have been simple when it was not, resource bound? Kind of a thing. So I like that. Hey, this isn't, hopefully, I'm probably expanding the scope here too much because this is definitely a post scheduling thing, but it makes me think of another thing that's a possibility here is, okay, so one challenge that we've kind of always had in net attached def land is with CNI in general is say IPv6, right? Things happen dynamically to your network during a runtime. So I wonder if you could also have the driver be aware of what's happening to your pods during runtime. So imagine this, you've got an IPv6, you've got a workload and it uses IPv6. It uses Slack and it dynamically gets IP addressing and routes. Right now that's a challenge for us, but if there were something like a way to like listen to the netlink events for that pod, for example, potentially could we have a driver that does something like that where it like listens for that stuff and then say updates like the resource claim status and says, hey, this actually has different IP addressing and routing than we started with.
I think you just call it out yourself, everything, right? Because all the pieces are there. With Lionel's status on a claim, it's an object that can be updated at will, right? It's not a pod. It's not so kind of, we are not constrained, at least with the pod, as much as we are here with the claim. Though, having said that, you probably could update the status of a pod post in a runtime, right? Or flip it or what's not. But still, today you definitely will be like, after Lionel does his implementation, you definitely will be able to, because then, as you called out the path, right? You have a driver that listens on the events or just watches the namespaces or what's not to kind of identify that the IP got received, or maybe has some hook into I don't know whether you can have a hook to something. So you look for the event that the Slack got assigned. So this is something your driver has to handle, right? And then when it does, it sees something, it identifies which pod got it, and then updates the appropriate claim for that, right? And that's possible. That can happen post. And then not only that, what can still happen, I wonder whether we can have a workloads. I think Lionel, you were saying something about the what was that? Oh my gosh, what's the name for this? But basically, he passing data into the container, right, in the runtime. Because what the ultimate one more step out of this DAG I would want to have is wait until you get the IP for the workload, right? If I need to, maybe I don't. Or if I have a DPTK application, right, it shouldn't start until it's know what's IP to use, for example, right? Because it might need an IP before it can start, right? How to do that, right? Because if you just keep failing, maybe you can keep failing the pod and just container will just keep restarted, and maybe that's fine as well. But maybe there is some ways where you can then pass the data into the pod as well, so that the pod can itself wait for its own data, right? Oh, I'm waiting for an IP, right? But I think you can, since you're inside the pod, you can wait for it in other means rather than through API. So maybe I'm overcomplicating things, but that definitely can help for in a future service, right? Serviceability, right? Because then, okay, we wait for that. If something changes on that object, right, the resource claim, it gets updated. Let me now add that endpoint post fact, right, to the set of endpoints into endpoint slice to kind of, okay, now you have a new endpoint to route your service into, right? So yes, I think that's all possible, and I think with all the pieces that we currently have, you can definitely do that, right? This is not hand waving now; it's an explicit path to do that, right? The only thing maybe hand waving is how you get the event of Slack assigning an IP to the interface, right? That's the only thing you would have to figure it out. Otherwise, the driver just updates the claim when it sees that IP, and you're done. So I think this is not. You won't be blocked by when we have all the pieces in, you will be just unblocked to do something like that. Yeah.
Cool. Yeah. Yeah. You just have my creative juices flowing because, yeah. So, good stuff.
Yeah. So, having said that, so I think what do we need is, so we have our pod network. We have a pod referencing the claim template name as a pod network name, and then we create our own template. The question here would be, what are the slices is, because this should be the generic way, as you said, right? As we kind of the two ways. The slice should be owned by the driver itself. So the implementation, then it's on completely on the side of the implementation, how you expose the capacities per node or per cluster, whatever you want to have, whatever approach you wish to have. And then we just need to ensure how do we define this data here, that it's flexible. I think this is what, Lionel, you have been calling out last week, where if we take this over, we might hide something. And this is something that we need to define. Okay, how do we explicitly control that? I think this is something that we need someone from the DRA to maybe give us some hints on where we could do and how we could kind of define those data, those structures in such a way that it is flexible, whether it's from device class, because what we could definitely do is have inside of maybe provider should still be here, but then we can have something maybe in pod network, something like a device class, right? Name or something like they have, and that will be the name of the device class, the DRA device class, right? And that's, let's say, it will be ns/name, right? And then your pod network uses this, right? And this will be optional. We have some defaults that we can create, but if you want to go very sophisticated way where you have sub resources or what's not, and you have to have additional scheduling capabilities, you can specify this, and inside the device class of the array, you can then add your own sophisticated ways of which drivers traditional to call for, and those drivers will be responsible for giving that sophisticated scheduling data. But I think this is maybe we need to see, because this one I would like to make this one optional. But then if I make this optional, what will be how this would behave when it's not optional? So right, so what other things we need to identify, what is the default approach that a device can do, right? And kind of to fit into, right? what I'm getting by that is, let's say I don't want to deal with or require from users to create the classes themselves to kind of completely obscure in my implementations, for example, for multi-networking, I completely want to obscure the DRA aspects. So basically, is there a way to me to define through this an API where I know what's going to be created in the template in such a way that whenever I create my device, it can easily report a specific resource slice that then is being properly understood here. So we have to have some APIs defined here of how we connect those two right together. So I think this can be maybe by just the driver name, right? The driver name, maybe that's what's needed, or driver name equals provider, and then that's what it can be, right? But I think this is something that we need to dig into further. We are almost at the time. Anything? Any other question on this? I think we still have some opens onto. Let me maybe write them down. Opens. And then the other one. Resource claim template. Yeah, let me just copy paste this guy. Any other comments? Probably something will be written here more, but I think in general the resource slice and what we said that we want to push all right. I think we are almost at the time. I think next week we are off for KubeCon. Let me cancel that. And then in 2 weeks we can get back. I hope Lionel and Doug, you're gonna have some update for us. Is there any inputs from the meetup next Monday?
Cool. Yeah, sounds good.
Yeah, hopefully.
What is the next thing to tackle in the DRA? I think we need to write down most of it what we discussed so far. Any other major gaps? Anyone?
There's virtual devices. I don't know if we should do anything about it. It's related to scheduling, so.
So this is where, yeah, that's fair. Is there something already written about this? That was just an idea thrown. Is there a doc about this?
No, I don't think there's any docs about it. I think it was just covering all the VLAN, VXLAN type of interfaces and similar. Maybe John has some.
Yeah, let me talk with John. Maybe he will know something. But still, yeah, let's look at that. But I am hoping the virtual devices will be still part of the slice, and that should be just basically covered by that, right? And it's up to your driver how you handle that. Maybe that can help us in some ways into this second question here, the second open, on how maybe we can standardize inside of the template versus the driver, right? And how it can create the slice itself. But yeah, but on the other hand, I wouldn't want to make it rigid so that only virtual devices would work. So this is where I think a user should be able to do whatever, right? So resource slice is what you have to create, whether it's a sub resource or just a normal device or virtual device. I hope that's all just implementation details on the drivers, right? So that, I don't think that should be hopefully putting anything on our side here to kind of have that handled. That's my hope here on this. Same like they did the sub resources is just part of resource slice. As I said, since we are not abstracting that, it's your device's job to kind of fit into all the new features, right? And however you want to use. And then from our point of view, we just use the scheduler, which should work with all those capabilities, right? Accordingly. Do you see that, Lionel? What I'm getting at?
Yeah. Just I have no idea how it should work at the end.
Sure. Yeah, we can walk through it and let's see what's there, and I will try to talk with John on this, or maybe invite him here. Maybe he can have some time to in 2 weeks to kind of give us some rundown. Okay, we're out of time. Thanks everyone. Meet you in 2 weeks. Have a nice KubeCon. Anyone attending?
Thank you.
Yeah. Thanks. Bye.
Bye.